section then in Chapter 5 was all about the basic identities. Pretty much all of the identities that we had reviewed from Algebra 1, or Algebra 2 last year. So we've got the reciprocal identities. We've got the quotient identities. We've got the Pythagorean identities. How many Pythagorean identities are there? 9. I really encourage you to just know what, though? The 3 major ones. Sine squared plus cosine squared equals 1. Tangent squared plus 1. Tangent squared plus 1 equals secant squared. And cotangent squared plus 1 equals cosecant squared. And then you got the 2 variations of all 3 of those sets, giving us a total of 9. So the reciprocal, the quotient, the Pythagorean, the cofunctions. What goes together with cofunctions? What's your pairing on cofunctions? Sine and cosine, secant and cosecant, tangent and cotangent. But your angles are complements. Okay? So the sine of theta would be equal to cosine of 90 or pi over 2 minus theta, so on and so forth. We then had the even and odds. The even and odds dealt with negative angles. Sometimes we move the negative from the angle out to the trig function. Sometimes we just disregard the negative. We disregard the negative if it's even. Now, what are the only 2 functions that are even? Cosine and secant. So the cosine or secant of a negative angle just becomes cosine or secant of the positive angle. You just drop the negative. But what do you do with the other 4? Sine, tangent, secant, cosecant and cotangent. What do we do with the negative there? We bring it out in front. So the sine of a negative angle, sine negative x, is really the same as negative sine x. Okay? And then what we looked at was just simplifying expressions, solving some equations that involve them, so on and so forth. We looked at the examples. Now we're going to go to your questions. What do we have off 5-1? Austin, go ahead. 30. So use basic identities to change the expression to one involving only sines and cosines, and then if possible, simplify it to just one of the 6 basic. Okay? So we're going to get everything in terms of sines and cosines, and if it's left with just a sine and cosine, we're done. But if it's like a 1 over sine, we're then going to change the 1 over sine back to a cosecant. Okay? So number 30. What is indicated to us to do in number 30? Yeah, we're going to change things in, but a FOIL is recognized here, right? How did you recognize the FOIL, Austin? 2 sets of parentheses. We got a binomial times another binomial. How do we multiply binomials? We FOIL. But this one's not a full FOIL. Why? They're conjugates, right? These are conjugate pairs. The only part that I need to worry about is the first and the last. So what is a secant times a secant? We're going to get a secant squared y. This and this are going to knock each other out. So now all I need to do is then the last. Well, a negative times a positive is a negative. Tan y times tan y is tangent squared y. Which now I'm looking at that and potentially thinking of what? Pythagorean identity. Why am I thinking of Pythagorean identity right there? 2 squared held together with a subtraction. That should be an obvious potential Pythagorean identity for us. Okay? Now, what is the identity that deals with the tangent and the secant, though? We know, because hopefully we're memorizing the main form of this, tangent squared plus 1 equals secant squared. So tangent squared plus 1 equals secant squared. Well, what would happen if I moved the tangent squared across? We would get what? Secant squared minus tangent squared would be equal to, is that a Pythagorean identity for us? Yep, the top gets simply replaced with 1. So 1 divided by, and secant. I really don't need to change that at all. I mean, if you wanted to change it to a what, you could. If you wanted to change it to 1 over cosine, you absolutely could. I don't need to, though, because I recognize that 1 over secant is what? Cosine. If cosine is 1 over secant, or I'm sorry, if secant is 1 over cosine, then cosine is 1 over secant. Well, 1 over secant then is going to leave me with cosine y. With cosine y. But if you wanted to here, if you wanted to get a complex fraction, absolutely you can. But I'm not going to divide by 1 over cosine. We're going to multiply by cosine over 1. And am I still going to get cosine? Yes, absolutely we will. Okay, so either one. All right, with 30, Austin? Where did you get hung up, if you don't mind me asking? This part? So the recognition of the Pythagorean? Okay, good. Number 6.
For that question, could you still take an out for sine over cosine? Because that's what I did when I got.
So you're saying right at the beginning, change everything to sines, cosines? Very difficult. Yep. Yep. Yours was probably twice as long as mine, or probably like 10 times as long as mine, right? Absolutely. What Will's asking is, so can I change this to 1 over cosine minus sine over cosine times 1 over cosine plus sine over cosine, divide by 1 over cosine? Absolutely you can, but do you see why he had a little more difficulty with it, though? Yes. When I can see that there's multiplication indicated, that multiplication would be done easier with just regular trig functions as opposed to fractions. So I'm going to do the indicated multiplication or operations first, and then once I get it simplified, then I'm going to change things back. Okay? But you can do it either way. One's going to be a lot longer, one's going to be a lot shorter. Okay? 6. Directions are then to use identities to find the value of the expression. Use identities in 6. Okay, hopefully there is a type of identities that is kind of jumping out at us. And what type of identities are hopefully jumping out at us here? Y cofunctions. Pi over 2 minus something, right? Pi over 2 minus theta is the complement of what angle? Theta. Theta. So if we had theta plus pi over 2 minus theta, what would happen with the two thetas? They'd cancel out, and I'd be left with, which is 90 degrees, right? So the complement of pi over 2 minus theta is theta. So we should be thinking here co-functions because we got a complementary angle, okay? Well, what the identity tells me is that the tangent of pi over 2 minus theta would be equal to what? What is the cofunction of tangent? Cotangent, and what is the complement of pi over 2 minus theta? Just simply theta, right? Just simply theta. So the tangent of pi over 2 minus theta is equal to the cotangent of theta. These two are complementary angles, cofunctions. Cofunctions of complementary angles are equal to each other. Do I know what this is equal to? They flat out told me it was equal to what? Negative 5.32. So what is cotangent theta equal to as well then? Negative 5.32. Okay, so we just had to show our cofunction relationship here, and now we can replace both of these. If this is equal to negative 5.32, then that's what cotangent theta is equal to as well. Cofunctions of complementary angles have to be the same. All right with that one? Good with that one? Now, later on in the unit, when we talk about the sum and difference of two angles, we'll be able to expand this out as well and simplify it down for even more than that. Okay. All right with 6. What else do we have question on? Connie? 24? Simplify to either a constant or a basic trig function in 24. A constant or a basic trig function. Okay. Any operations indicated to me in this one? There's no parentheses, right? And parentheses always indicate what? Multiplication. I've only got one fraction. There's not two fractions. If there were two fractions, it might be indicated to me that I have to add or subtract them to get a single one. But there's no operations indicated to me in this one either. Okay? So, Will, what should be the first thing I do then now in this case? Everything to sine cosine now. There's no operations that are indicated to me. There's no factoring that I can do here. There's no GCF. There's no dot. Can't be trinomials. There's no operations that are indicated to me here. So what's the only thing I possibly can do? Try to get everything back to sines and cosines. Okay? So the 1 is going to still stay 1, but it's going to become a 1 over 1 because everything else is going to become a fraction. So this is going to be 1 over 1 plus, what's tangent? Sine x over cosine x. Divided by 1 over 1 plus cosine x over sine x. We now have a what? What do we call this from Algebra 2? We call this a complex fraction, right? A complex fraction is fractions among fractions. Do I want multiple fractions in my numerator? No, I only want one fraction in my numerator. Do I want multiple fractions in my denominator? No, I want one single fraction in my denominator. Okay? So am I looking at this all together as one thing? No. I'm first going to cover up the denominator, and I'm going to add the two fractions in my numerator and get one single fraction. I'm then going to cover up the numerator and look at the two denominators and add them together to get one single fraction. And then I'm going to have one single fraction divided by one single fraction. How do we divide fractions? By multiplying by the reciprocals, right? So let's just focus on the top. What would the common denominator up top be? Cosine x. Well, 1 is the easiest possible fraction you can work with because 1 can be anything divided by itself. So what would 1 be in terms of having a cosine in the denominator? Cosine x over cosine x. Okay? So cosine x over cosine x. Is that still 1? Absolutely it is. Well, now can I add them together, though? Yes. And my denominator is going to stay what? Cosine x. It stays the common denominator. But what am I going to get up top? Cosine x plus sine x. So cosine x plus sine x divided by cosine x. Do I now have one single fraction as a numerator? Well, let's do that same thing in the bottom. What's my common denominator in the bottom going to be? Sine x. So what is 1 going to become? Sine x over sine x. Plus cosine over sine x is going to be equal to? Yeah, either sine x plus cosine x or cosine x plus sine x. I'm going to write it cosine x plus sine x because that's what we have up top over sine x. So now I have one single fraction over one single fraction. How do we divide fractions? We multiply by the reciprocal. So I'm going to have cosine x plus sine x over cosine x. And it's going to get multiplied by sine x over cosine x plus sine x. Do we need to worry about a common denominator for multiplication and division? No. No. But before we multiply or divide, we'd like to see if we could do what? If we could cancel some common factors out. Do I have some common factors that I could cancel out? Absolutely I do. They both have a what? A cosine x plus sine x. One in the top, one in the... Those two factors that are exactly the same are going to knock each other out. I'm going to be left with sine x over cosine x, which we know better as tangent x. Tangent x. I always thought that was the easiest way to simplify a complex fraction. Simplify the top to one fraction, simplify the bottom to one fraction, and then divide fractions. But was there another way that we looked at simplifying complex fractions? Looking at the way we just did it, we had to find how many common denominators? two. One for the top, one for the bottom. Was there a method where we just looked at everything and found the common denominator for everything? Yes. Yep. So we had 1 over 1 plus sine x over cosine x, 1 over 1 plus cosine x over sine x. What would the common denominator for everything be? Cosine x sine x. What did we then do with that common denominator for everything? We distribute it to everything. Okay? So up top here we would have gotten cosine x sine x plus if I multiply this by a sine x cosine x, the cosines will cancel and we'll be left with sine squared. Sine squared. Okay? So cosine x sine x plus sine squared. Down here this would again be cosine x sine x, but this would be plus cosine squared. Well, up top, both of the terms have a sine. Well, if I factored the sine out, I'd be left with cosine plus 1. In the bottom, they both have a cosine. So if I factored the cosine out, I'd be left with a cosine plus 1. And then the cosine plus 1s would cancel out. Sine over cosine, which is still tangent. Does it matter either way? No, it does not matter whichever way you simplify a complex fraction. If you want to find a common denominator for everything and distribute it, or if you just want to work top and work bottom and then divide the two, it does not make a difference. You'll get the same answer either way. You just got to make sure you show what you're doing. Okay. So all right with 24, either method? Good with that one? Other questions we've got? 33? Directions. Combine the fractions, simplify to a multiple of a power of a basic trig function. So example, a multiple 3 times of a trig function, of a power of a basic. So we want something that would look like that on 33. So, what is being indicated for me to do here? Add fractions, right? I got to have a common denominator then, right? So over here I've got a sine squared. Over here I've got a tangent squared. What would the common denominator be? Sine squared, tangent squared. So what does the one on the left need? So it would be tangent squared x. And we already know our common denominator is sine squared x tangent squared x. Plus, what does this one need? So it would be sine squared x secant squared x. Yep, and again, you're going to get there. It's just going to be longer for you. Okay? I'm always going to do the indicated operation first, and then I'll make it difficult. All right? And now that I'm at this point, what do I want to look to try to do now? Now I'm going to change everything. So this is sine squared x over cosine squared x plus secant squared is really 1 over cosine squared. So this is also sine squared x over cosine squared x. Because secant is 1 over cosine squared. So sine times 1 over cosine squared is going to be sine squared over cosine squared. Down in the bottom, tangent squared is again what? Sine squared. So what's sine squared times sine squared? Sine to the 4th over cosine squared. Can I combine up top? How did we get sine to the 4th? Page? Okay. So sine to the 4th over cosine squared. All right. Can I combine the terms up top? Absolutely, I can combine the terms up on top. how many sine squared x over cosine squared x? 2 sine squared x over cosine squared x divided by sine to the 4th x over cosine squared x. How do we divide fractions? So we're going to multiply by cosine squared x over sine to the 4th x. And what will happen? Bless you. The cosine squareds will cancel out. 2 of these sines will cancel 2 of these down here. So sine to the 4th is going to become sine squared. And I'm going to get 2 over sine squared x. Well, folks, saying 2 over sine squared, exactly, it's the same as saying 2 times of 1 over sine squared. Well, what is 1 over sine squared? Cosecant squared. So we get 2 cosecant squared x, a multiple of a power of a basic trig function. We have cosecant squared, 2 times of it. Okay, good with that one? Okay. Again, folks, could I have taken care of this complex fraction by finding the common denominator of everything? Yeah, and what's the common denominator of everything here, folks? So they're all going to knock out, and it's going to leave me with 2 sine squareds over a sine to the 4th. End up at the same spot, though? Yes. It's going to end up at the same spot, though. All right with 33? Good with 33? This stuff, all of these questions that you're asking are vital for us in our proving of identities, because we need to be able to simplify trig expressions down. Okay, simplifying expressions down is very important. Other questions? Connie? Find the solutions to the equation in 51. Okay, you'll remember last year when we were solving trig equations in Algebra 1, there were 2 red flags we needed to look for. The first red flag is that all of my angles had to be the same. What are my angles defined by up here? X. Are all of my angles the same? Yes, that was our must-have. We had to have all of our angles be the same. Okay. The second red flag is that we would like them to all have the same what? Trig function. We'd like them to all have the same trig function. Do they all have the same trig function up here? No, we've got 2 of them that have cosine, 1 that has sine. Well, is there any way with identities to turn that sine into a cosine? No. Is there any way with identities to turn a cosine into a sine? No. What if it was a sine squared? Could I change a sine squared into a cosine? What identities do we think of with squares? Pythagoreans. Is there a way to change a sine squared into a cosine? Yeah, sine squared would be 1 minus cosine squared. But there's no way to turn a sine into a cosine or a cosine into a sine. Okay? But that wasn't a must. We could deal with different trig functions. How many terms do I have up there? 2 terms, right? There's 1 term minus another term. Do those 2 terms share something? What do they share? They both have a cosine x. Well, if those 2 terms share a cosine x, what can we do with it? We can factor it out, right? And if I factor that cosine x out, what will I be left with? 2 sine x minus 1 equals still. I can deal with having different trig functions because hopefully we'll be able to do what to separate them? Hopefully we'll be able to factor them out and separate them away from each other. What do I now do? Zero factor property. What is each one of those going to be equal to? So cosine x equals 0. And sine x is going to equal 1/2. Is everybody all right with that? I mean, 2 sine x minus 1 equals 0, but then we're going to add 1 divided by 2. So sine x equals 1/2. Okay? Now, I think the directions were including 0, but not 2 pi. 0 to 2 pi not included. 51. We can include 0, but not the 2 pi, right? Okay, so this is which trig function? Cosine, and where is cosine 0? That's pi. Pi over 2 and 3 pi over 2. Pi over 2 and 3 pi over 2 is where cosine is equal to 0. Here's sine x. Okay. So it doesn't really help us much, though, because the 1/2 are right here. But this is one of our special values, right? 30 degrees, which is pi over 6. And then how do I put 30 into quadrant 2? Adding 180 is going to put me into 3. Subtracting from 180, right? Subtracting from 180. So I need to take a 1/6 away from a whole. 5 pi over 6. So pi over 2, pi over 6, 5 pi over 6, and 3 pi over 2. Can I check all of these? Absolutely. We store all of them as x, and we type them through the original, and you're going to get 0. It's going to check out for you. Okay? So pi over 2, pi over 6, 5 pi over 6, and 3 pi over 2. Okay? We've got to have our angles be the same. And if they are, we can deal with the different trig functions. Hopefully we'll be able to factor them away from each other, and then zero factor property. All right, 51. Good with that one? Other questions we've got from the homework assignment, folks? 45. Directions are, again, to factor. So 45, we've got to factor down. 45 is a good one. Hint, hint, hint. 45 is a good question. Okay. So I have 4 tangent squared. Well, again, saying 4 divided by cotangent is really the same as saying 4 times 1 over cotangent, right? But we know 1 over cotangent x much better as, what is the reciprocal of cotangent? 1 over cotangent is equal to tangent. So this is really minus 4 tangent x. So 4 tangent squared x minus 4 tangent x, anything times its reciprocal is always 1. Anything times its reciprocal is always 1. Now does that look a little bit easier to factor? Okay, now we've got the general trinomial. But instead of the general trinomial being in terms of x, it's now in terms of tangent x. It's now in terms of tangent x. Okay? Cheyenne and I were looking at one like this earlier, and she was getting confused with the tangents and making this look a lot larger than it is. Is there any reason why I cannot make a quick little substitution like this and say, I want to let y equal tangent x? And now what would this be? 4y squared minus 4y plus 1, and factor it like that? Is there any reason I can't do that? No reason at all. Just make sure at the end you come back and replace your y's with tangent x. There's absolutely no reason why you cannot do that. Okay? I'm looking at this one, though, and saying I might want to use x method because of this right here, but then I look out here and say, no, it's not going to be necessary. or the only factors of 1? 1 and 1. This means they have to be same. They both got to be negative. I don't need to do this. It's going to be 2 tangent x minus 1 and 2 tangent x minus 1. What's 2 times 2? 4. What's 2 times negative 1? And another negative 2 gives me negative 1 times negative 1 is. So instead of saying this, we're going to just say 2 tangent x minus 1 squared. 1 over cotangent is tangent. So 4 tangent squared minus 4 tangent. Anything times its reciprocal has got to be 1 plus 1. Now I have the basic trinomial that I can factor. All right with 45? 45. Any other ones, folks? Anything else? Yep. 36. Combine the fractions. So again, we want a multiple of a power of a basic trig function in 36. And again, in 36, what operation is indicated to me here? Subtraction. Subtraction of fractions. I've got to have the common denominator, right? Well, over here we have a factor of what? Secant minus 1. So over here I need a factor of what? Secant x minus 1. Over on the right we have a factor of secant x plus 1. So on the left I need a secant x plus 1. The numerators are kind of easy because it's just 1. Multiplying by 1 does nothing. So we're going to get a secant x plus 1 over, remember how we did this last year? Is that still legit? Fine with that. Minus a secant x minus 1 over LCD. Well, now do we have the common denominator? Well, once we have the common denominator, can I subtract? Well, what's the only part that gets subtracted, though? Just the top. So what is secant x minus secant x? They're gone, right? What's 1 minus negative 1? Positive 2. 2 over secant x plus 1, secant x minus 1. So we're getting there. Now we've got our multiple. But this needs to become a power of a trig function. What's indicated to me to do to them? Foil it out, right? But do we have to do the full foil? Why not? They're conjugates. What and what? First and last. So what's secant x times secant x? Secant squared x minus 1. And that should be a red flag for a what? A Pythagorean identity. What is the Pythagorean identity that deals with a secant? Not cotangent. Nope, S and T go together. Tangent squared plus, not tangent squared plus secant squared, tangent squared plus 1 equals secant squared. So what does secant squared minus 1 equal? 2 over tangent squared x, which is the same as saying 2 what squared x? Cotangent. A 1 over tangent is a cotangent. So we have 2 cotangent squared x. 2 cot squared x. We've taken something rather difficult and turned it into something pretty simple. Okay. All right with that one. Good there. That's about as much time as we got. We might be able to get a quick one in. Is there a quick one, Austin? 63? 16. 6D. There is no 6D. I know. Solving the equation again. No calculator on 60? Okay, so again, are we dealing with the same angle? Yes, we are. But do we have the same trig function? No, we don't. But can I change a cosine squared into a sine? Yes, I can. 3 sine t is equal to 2. What are we going to change cosine squared to? Not sine squared minus 1. 1 minus sine squared. Because sine squared plus cosine squared equals 1. So cosine squared's got to be sine squared, or 1 minus sine squared. See. Now is everything in terms of the same trig function. I've got to do some distribution over here, though.
May I have attention, please? The afternoon announcement. The golf match today at Ellicottville has been canceled and rescheduled for tomorrow. However, you will have practice right after school today. The drama club is in need of shoe boxes. If you have an empty one, you can donate. Please bring it to the chorus room. Following students, please report to the office. Jordan Milks, Dawson Galecki, Bill Schwait, Madison Wozniak. Thank you for your attention.
Standard form. Moving everything over to where the squared is positive.
The following students, please report to the guidance office. Anthony Settaplate, William Bartholomew, Brock Leisha, Caleb Goodell, Allie Haskell, Morgan Howard, Caitlin McGee, Brett Mays, Amy O'Neill, Daryl Tate, Cindy Willigert, and Caleb Block. Please report to the guidance office. Thank you.
2 minus 1, 1 plus 2, because 2 times 2 gives me, and 4 minus 1 gives me the 3. And now I'm setting each one of these equal to what? So sine t equals what? 1/2, and sine t equals, red flag right here though. Sine can never be equal to -2. Sine can only be in between think of your sine curve. Sine only fluctuates between where and where? -1 and +1. That cannot happen. Sine fluctuates, sine and cosine, in between -1 and +1. It'll never be -2. And over here, when is sine 1/2? 30 pi over 6, and the 5 pi over 6. So t equals those two. Okay? Have a good one, folks, and we'll see you tomorrow.